All right. So let's continue where we stopped in the last class. If you remember, we are discussing about disk management, and we have seen the initials. So like let's say what we did, we created we created we have a disk. We attached the disk to our server. We created partitions out of that, and of course we have used it, deleted it. Format it with some file system, mount it, permanently mount it, and use it. That's what we did so far. But one thing we have discussed is increasing the size or decreasing the size of partition, which is not possible. Increasing the disk size, it's manual. So whatever the disk we attach to the system, that has to be increased. That is a different thing. But let's say we have partition in this disk. So partition maybe let's say 2 GB. I want to increase it to 3. By default, it's not possible with app disk. By default, it's not possible. But we need to increase and decrease. That's the requirement, basic requirement, right? So that's what we were discussing last week, how to do the increase and decrease of it. That's where the topic LVM comes. LVM. Sorry. Logical Value Manager. Logical Value Manager. So what happens is, with this LVM, we can able to create a volume, or partition. Obviously, as we volume, the name it's volume, but it's a partition. We can able to do it, and we can extend the partition. Let's say 2 GB, as I mentioned. We can increase it, and we can decrease it also. Maybe 2 GB I create. I don't want it. Uh, we can able to do the decrease also, for maybe from 2 GB to 1 GB. That also is fine completely. It is possible with all this, with LVM, with this concept. So everyone uses LVM. You know why? Because that the basic requirement for a disk is to increase and decrease. What's the point of if we can't do that? There is no point, right? So that's why everyone uses it. Of course, they'll create a disk. You have disk to create partition. Sometimes the people use it. If they don't want LVM, they want a single disk, they'll just simply format that disk and I mean, what is it? They just simply format it, they'll use it, they'll mount it, and they'll use it. But if we want to increase or decrease, LVM is the concept. So how to do that? But yeah, let's see how a LVM will look like. This is the structure of LVM. Starting from below, not from above. Starting from below, let's see how it looks like. There are a few stages. So the process is usual. I mean, first we create a partition, obviously, which is fine. Next is, let's say the partition is ready, but don't format it, because once you format it, you have to use it. There is no point of, once you format it, once the file system is assigned, you cannot change it, like, disk type and everything. So first we'll create a partition, and then we'll create a physical volume out of it. What does it mean physical volume means? In order to create uh, LVM, you not use LVM, we need to follow this procedure. So starting from, see, observe the arrow mark, I think it's visible. First we need to create a physical volume, then volume group, and then logical volume finally. We'll explain all those things. What are those? Logical volume is the last one where we create a volume out of our disk, sorry, a partition whichever we created, and this logical volume can be increased, can be decreased. So logical volume is the last one. So once the logical volume is created, we'll format it with the file system and we'll use it. That is the last step. But to do that, we'll start from physical volume. First, we'll create a physical volume. What does it mean creating a physical volume means? So out of our partition, we're converting that so that it can be used with LVM. It can be used as LVM. We created our normal partition. While creating a partition, we'll select it. The partition type, like LVM partition type, we'll select. And once the partition is created, earlier our partition is created, we'll simply just convert that into physical volume. Why? Because in order to use LVM, logical volume manager, in order to create the logical volumes, first we need to convert that to physical volume. Next what we have to do is volume group. I think by now you might have observed multiple physical volumes into a volume group as a volume group. So as I told you, physical volume is nothing but a partitions whatever we created. We just use one command to convert that into physical. There's nothing will change. But to use logical volume, this format is required. That's it. There's nothing changes really. So we have created a partition. We'll use one command to change. To update that partition into physical volume. That's it. That's why there are three boxes, means three partitions. And what we are doing here, we are creating all these partitions as a group. Let's say 10 GB, 10 GB, 10 GB, 30 GB as a volume group. VG, as a VG, we call it VG. So out of that 30 GB, now it's a 30 GB, right? I'll create logical volumes, maybe 1 GB, 2 GB, 3 GB, and limited. Limited. There is no limited over there. So whatever volume groups, whatever the logical volumes, I will create out of the volume group. It does not so the partitions are 10 GB size. That does not mean logical volume should be 10 GB size. You can create any size starting from 100 MB, I think. Yeah, 2048, yeah, sorry. Starting from that MB to whatever the limitation, what is maximum limitation here, 30 GB, until 30 GB, like that. As an example, maximum size of volume group. So we create multiple, these PVs are nothing but partitions to keep it simple. And the partitions will create as a group, and from that group we'll create our own volumes. LVs we call it, volumes also fine. Whatever the size we want. And those volumes are created, right? Once they are created, we'll format them and we'll use them. We'll mount them and we'll use them, just like our partitions. All these because we want to increase or decrease the volumes. The capability will come if we follow this approach. So I don't want to increase the size of or decrease the size of a disk, partition. I just want to use as it is. Simply create a partition with the F disk or G part, whatever. Format it and mount it, use it. That's it. There is no need of this. This needed when we want to have a capability of increasing or decreasing. Got it? So before this we create a partition, convert to physical volume, add that volume, create a volume group, add these volumes to this volume group, and then create a LVs out of this volume group. And then of course file system, if C means format it and use it. So let's see how to, starting from first create a partition. Obviously if this is my disk, let's create a partition. F disk, no, sorry, XPDF. Sorry. Only root can edit the partitions. Ubuntu is a normal user. He don't have access by default. That's why. There is something called a partition table usually. So it will print simply the partition information in this disk. Since there are no partitions, just a disk for now. Nothing is printing. Just prints you. So first I'll create a new partition. Obviously n. Obviously primary partition. Partition number 1, yeah, it's fine. First sector, okay, this is fine. Last sector is the size which I want to give. Maybe I want to give 8 GB, let's say. Yes, 8 G. Partition contains an XFS signature. I do yes. Next, the partition is created now. Let's type T. You know what is T used for is hex code or alias. Hex code is, see, we are creating a partition, right? These are all the types of partitions we can able to create. 0, empty, FAT32. So many are there. FAT16. W95 is Windows. I mean, so many are there. What we want to do here is what I'm trying to do. We are creating a partition and we want to use it for LVM. So that this partition should support that LVM concept to convert that into physical volume, to convert that into volume group like that. So that's why there is a type in this called where is it? 8E. It should be here somewhere. So we have to create the volume based on the type 8E. Here, sorry. So here what happens is, let's use 8E. See, partition type has been changed to 8E to Linux LVM so that this volume can be used. Without selecting the type, LVM does not know anything. Okay, it's just a normal partition. I cannot use that. But if you change the type to Linux LVM, so for LVM concept it will become easy. That's why we use it. We have to change the type to Linux LVM. Once we select the final sector, I mean the last sector. I mean once we choose the size of the last sector, then you have to choose. This is fine. It is the last thing. Forget about it. You won't see this. But yeah, once you choose the last sector, the size of it, you can just simply type type T, just T. It will show you all the list. Type L, capital L. It will show you the list. Out of these, select 8E, well, LVM, and obviously save it. Then LSB, LK. See, out of 10 GB, 8 GB partition is created. Out of this partition, I'll create LVMs. Not necessarily means 8 GB as I told you. So it can be 1 GB partition, LVM partition, 2 GB, 3 something. I'll create it like that. Let's see how to do that. So now my partition is ready, XPDF1. First what we have to do, create a physical volume out of the partition. pv create /dev/xpdf1. Physical volume successfully created. Yep. That's it. Simple. Now 2 more GB is free, right? Let's create one more partition. Now we can convert that also as physical volume. That's fine completely. I mean, so left disk command n. Now see primary partition, obviously. See the number 1 is already taken, right? Default is 2 now. Okay, let's keep it 2. That's fine for me. First sector, yeah. Second sector only 2 GB is free. Maybe I'll just create this 1 GB. Linux, you see 954 MB it took. Now change the type to LVM T. have to choose the partition number, because last time just one, so directly it showed us the types, but now there are two partitions. Which partition you want to change the type? Partition 2. Hex code I know it already, so X8E for LVM. See, W, save it. Yeah. Now try it. LSBLK. See, out of 10 GB, I created two partitions. One is 8, one is 1 GB. I mean, 154 MB, obviously. So out of that, one PV is already created for XVDF1. Let's create for second one also. Physical volume is successfully created. It does not do anything extra. It just creates a volume, physical volume. That's it. Now to display this, just type PV. Sorry, PVS. See, physical volume just created. That's it. Okay. In the LVM2 LVM format. That's it. So that we can able to use this for LVM concept. That's the only thing. PV create. PVS to display it, or PV display. It will show larger information. See, we call it PV. Don't need to call physical volume. It's PV, PVS, PVS or something. PV is fine. Next, we want to create a VG out of it, on volume group. Correct. So there are now two volumes, to means two partitions. We cannot use them directly. So we have to create a group. With one also you can able to create a group, or with two also you can able to create a group, and we have to use it. So what we tried for PV creation, PV create, right? Now for VG create, I mean volume group create, VG create, VG create. That's it. But here you have to give some name to group. What name we can give? Maybe VG data, VG data, something, some name. You have to identify that. Now what are the partitions that you want to use? /dev/xpdf1, because this one we already converted to physical volume, so that we can able to use this. And what is other things? xpdf2, this also we converted to physical volume, we can able to use it. Volume group VG data created successfully. So VG, now it's a group created, volume group is created with these two physical volumes inside that. VGS, same thing. VGS or VG display, anything. Observe here, two PVs are there. PV means physical volumes. LVs are 0, I haven't created it. See the size here. Now it combined as a group. There are two physical volumes. One is 8 GB and 900 MB. Now it combined as a group. Out of these, you can able to create LVs. You can able to create LVs. LVs. Those LVs will be using formatting, and will be mounting it using it. So you can use 8.9 GB directly to create one LV, which is fine. You may think, okay, there are two partitions, how can it create? But now it's LVM and it's a volume group. Now if a group means it's one, right? It's just one. So you can able to use the whole size also. That's completely fine. I mean, you can able to use anything. So like that LV works. Let's see how to create the LV. Simple, same thing. We seen PV create, VG create, something LV create. LV create. Sorry. Hyphen L, capital L. What is the size you want? Maybe 3 GB. 3 plus 3G you can able to use. Hyphen N. You have to pass the name to LV. LV1 as an example. LV1. I'm just kidding. No need to give number. Just you can give name completely like that. That's completely fine. So LV create. I'm creating LV with logical volume with 3 GB. The name is LV1. Out of which volume group we are creating this? So what is my volume group name? VG data. From this volume group I am creating this LV. Like this. See, let's say you may have more than one volume groups. It's common, right? See, for now we just have one disk, so that I know I created one multiple two partitions and using them as a single volume group. Maybe in organization you may have multiple disks with multiple volume groups separately. You can, let's say VG data 1, VG data 2, blah, blah, something, whatever it is. While creating LV, you can choose whichever you want, whichever VG you want. So that this volume LV, I mean logical volume, will be created out of that groups. No, it will use that size from that group, the storage. I mean, like that. So make sure whichever uh, group you want to create LV from, you have to choose that. So LV create this all fine -l, the size -l, the name LV1, and VG data is where the our volume group out of which we want to create this LV. The volume is created. LVS, not C. See, 3 GB is created. You want to create one more? LV2. I mean, no need to, I'm telling you again, no need to give numbers. Maybe you want to create 300 MB, just for example. See, you can create until 8.9 GB, until this one, at 3.3 GB, I think 6.6 GB remaining. Now these volumes you can able to mount it and you can able to use it. Let's say format it first. These are new volumes. You have to format it. We have to assign a file system. Otherwise, you can't use it, right? mkfs. These commands we know it already. mkfs.ext4 /dev. Now this is important. What is the disk path? Usually last time we tried /dev /xvdf1. I think we have tried the xvdf1. That's a partition. But now here, this is not a partition. I mean, it's a partition only, but not a direct partition, right? And logical volume. So logical volume, how the naming convention is not xvdf1, correct? It will be /dev /vg name. What is the VG name? VG data and LV name, LV1. This is the LV path. So /dev is fine. VG name /LV name. This is the path of it. Format done. Mount it. You know it already, I think. Test folder is there. Simply mount. What is it? /dev / what is the VG name? VG data. What is LV name? LV1. Test. Done. Mounted. DFFNH. See, 2.9 GB. Whatever you store it, it will be here. Of course, you can do the other one also. That is completely fine. Let's do it. Okay, here test 2. First, we have to format it, right? LV2 formatted. Now mount it. LV2 to test2 folder. Obviously, sorry, 300 MB. Of course, it won't come fully. See, you can able to mount n number of, like these. There is nothing wrong in it. Correct? If you see here, observe here now. See the structure. VG data with the name LV, VG name, LV name. Like that, the name will be right. See, whatever we created, I mean volumes, we did not choose out of which partition we need to create, like xvdf1, xvdf2. We just created these two partitions as physical volumes and volume group, and we create LVs, I mean the volumes which we want to use. But the system itself choose which to use. We did not choose them, right? We did not tell that, hey, use xvdf1 partition, use xvdf2, like that. We did not choose that. System chose it by default. So when that is full, system choose another xvdf2, which is fine. I mean, we don't need to bother about it. We don't need to do anything at all. Okay, so that's the thing. So that's about creating volumes. Okay, so far great. I mean, we are, what is it? Creating a volumes, using it obviously mounted and everything. It's fine. Now the main thing, why we use the LVM? Because we want to increase, we can be able to increase the size and decrease the size of the volumes. Volumes means the LVMs, the LVs. So let's say before, you know, let's say PVS. I'm just giving you everything. VGS. Let's say LV we can able to increase. That's is fine. We'll see that later. But the VG size is already done. See, VG free is 5.6 now. It's zero. Is zero. Then you can't increase or decrease the size, right? Because it means it's already assigned the LVM to LVMs. The size is not free. And then what you do? Simple. Let's say you have space here in this volume. You create one more partition, maybe XVDF3, and add that, you know, to PV. PV create, add that here, and add that PV to AVG. That also we'll see. I'm just telling you currently before that. So first create an LV. LV I want to increase the LV. Just 265 MB is there. Maybe I want to 600 MB. Just for, I want to increase this one. What is the command? LV extend -L plus what I have to use. I want to increase 300, right? Let's try it. 300 M. Let's see what happens. Slash dev slash what is that? VG data slash LV2. You may think, hey, why there is a mapper here? Forget about it, because that's how Linux system assigns the naming convention. We don't need to use a mapper, it's completely fine. Or we can use it, that is also fine. Linux system assigns like that. So let's come here, LV extend, we are increasing 300 MB. See, read it, it's completely fine. But still I can't see it. Why? Correct, right? It's increased, but why the hell I can't see it? Because df minus h, as I mentioned, it will show only the mounted devices. Okay, ours is already mounted, and mounted devices with the file system. Correct. See, now what we did, we increased the size, but the file system is only applied to 300 MB only, because earlier we tried mkfs.ext4, right? So at the time, what happened? The size was 300 MB, so the file system was applied to 300 MB only. That size only. Now increased it. Now volume has been increased, but the file system not been updated to the latest updated size, the 300 MB whatever we added. Don't format it now. mkfs.ext4. If you do that, all the data will be gone. We cannot get it back. For existing disk, we increased the LVM size. At the time, what we have to do is, there is a command called resize to file system slash disk name, this or disk path. It will update the file system. Resize to fs command will update the file system. Let's see now. See, now it came. That's the thing. The thing is, when you apply mkfs.exe4, the file system will apply only to that size of whatever at that time it was present. Now the size has been increased, but the file system does not know that. File system does not know that size has been increased. So you have to use this command resize to fs to update the file system. Now what happens, it will look through this thing, and if there is any sizing required, see here, online resizing required. If there isn't, It will look for the size. Why this guy executed this command? Maybe something increased or decreased. It will look for the command, and then based on that, it will update the file system. So now size has been increased to 300 MB. Resizing is required. Resizing the file system is required. So it updated it. That's it. That's about increasing. Simple. Increasing is easy. LV extend, plus whatever the size you want to increase. Update the file system. Resize to FS. That's what. Two commands. LV extend, resize to FS. So hope it's correct. It's updated. Sorry. Now how to decrease it? How to decrease? Here we have to follow little few steps properly, because if you do something unexpected, we are dealing with the data right here, with the volumes which contains the data. Let's say organization data, company's data. If that's gone, there is no way getting it back. Got it? That's why we'll make it safe. That's why decreasing is difficult. Increasing is easy. That's fine. There's two commands: LV extend and update the file system with resize to FS. But decreasing also simple, but just make sure. So before decreasing anything, make sure you back up that data. Obviously, whatever is present. Let's say I want to decrease this one. I'll take a backup of this one. Now, next what I'll do is, first thing what I'll do, if I want to do this decrease, I'll unmount it. I mounted it right to root test 2. Now I'll be unmounting it. I am unmounted it. Obviously you can't see it now. Once unmounted, I'll execute one command: e2fsck -f /dev, what is it, /dev disk vg data /lv2. I'll explain what is this e2fsck. So what's happening here with e2fsck is, see, when we store the data, let's say there is a disk, there is a box. When we keep some items into it, it won't be organized right. It will be it will be covered in all this places. Like let's say we have boxes here. We kept three balls, let's say. They won't store at a specific place, right? They'll move around. Maybe one ball it's at a right corner, or another one is a left, another one somewhere. It will be moving somewhere. So there is no organize of it, because we cannot organize until it's full, maybe. So we cannot keep them all in one place. We cannot keep them all in right side or left side like that. It is random. Randomly it will be, the balls will be moving. The balls will be stored randomly in that box. Correct. We cannot control that. So at that time, let's say now you want to cut the box in half. You want to cut the box in half. What do you do? Let's say just simply blindly cut the box in half, but you do not know in which side the balls are. Let's say you're cutting, you want to throw away one half. Let's say left side half you want to throw away. So you want to cut the box, you want to throw away the left side box. But the balls present on the left side only. You don't know, because it's not organized, right? You don't know. So the balls will be gone along with the box, right? Now, that's what it happens. So instead of that, before cutting the box, you organize the box. Keep all your balls and everything in the opposite direction, maybe in the right side. And now you cut the box, and you can throw the box now, because those balls are present in the opposite direction. You just organized it. You got it? You just moved it to the right side and cut the left side of the box. So there is no data loss here. whatever the balls present inside this. So you can able to use it. Similar way here also. Same thing. Take any example, maybe uh, how to say, maybe luggage or something. First, we'll start keeping from one side, right? Just don't normally throw it, in the luggage, the suitcase like that. We'll arrange like that so that it will be, easy to organize. Imagine like you just throwing your clothes in the luggage bag. You won't fit it more, and if you want to remove something, you have to remove everything. Maybe your dress is at the bottom of the suitcase like that. Similar way in this also, E2FSCK in this Linux environments, it will organize your data. What does it mean is your data will store randomly in the LV. LV is came from VG. VG is came from physical volumes. It means VG contains two disks. So LV can be created, can be stored the data anywhere in those two volumes. That's how VG works. That's how LV works. So you don't know. That's why when you're organizing the data, it means it will take the data, you know, into one place. I mean, so it's a way we can say like organizing the data. Whatever data is inside, present, it's organizing it. Got it? What I'm saying? So it's organizing it. So now, okay, organization is done. I mean, sorry, UTF-SCK it is done. Next, what we have to do is file system update. What does it mean file system update? So you are decreasing the size. You have to, before decreasing the size, you have to update the file system. There is no need to update, right? I'm decreasing. That's what you have to decrease the file system. Let's say what is our size? 600 MB, right? I want to make it to maybe 400 MB. 200 MB I want to remove. So now after removing it will be 400 MB, right? Now you have to update the file system to 400 MB. Why? Because it will be unnecessarily wasted. I mean, so we're not using it. So 400 M, let's say. It means the new size is going to be 400. So the file system will be covered. So whatever the size is going to be after reducing the volume, that size you have to give here for file system update. And now do it here. LV reduce hyphen L, obviously. Sorry, capital L. 400 M. See. Do you want to reduce? Yes, please. See, reducing active volume to 400 MB. Yes. From 600 to 400. See, it's obvious. Type LVS. See, 400 MB. As simple as that. Nothing. Type history. First, what you did in you mount unmount the partition, organize the data whatever inside it to FSCK, update the file system with the new storage. How much storage after decreasing you will have. Of course, you will have an idea, right? So without that you can't decrease it. So maybe 1 GB is there. I'll be decreasing maybe 100 MB. It means the file system has to be there for 900 MB, like that. You know the size. What's the size after decreasing it? For that you have to update the file system so that you're not wasting it. And then finally, once the file system is updated to the latest size, LV reduce. So it's the same size. LV reduce, why I give 400 here is I want this size to be present. That's why. See, we're not giving here how much to reduce. Correct? We're not giving how much to reduce. We are telling, we are giving how much we want after reduce. Let's say 100 GB is there, volume is there. I just gave 400 MB here, just like this. I just give 400 means 99.6 GB will be deleted from this LVM. I mean, deleted means it'll just remove from LVM, it will be present in VG. So like that you have to do it. So you don't mention the what size I want to decrease. You mention what has to be present after decreasing. That you'll do it. Got it? Got it right? What I'm saying? Is this clear? See how I mention the size. That is important. Got it? Uh, any doubts so far? Anything? Any doubts? Once you this, of course, it will be a little confusing. At initial, but it will be very easy. It's fine. Once you practice one time, it will be too easy. It will be too easy. I'm telling you. So just creating a volumes and using it. That's it. That's the only thing. Got it? Anything? Anything else? I mean, any doubts so far? So just an extension of our existing disk. So last time we have tried like creating the disk hardware partitions and using it, but there is no possibility of increasing or decreasing the partition size because of sorry, because of the limitation with the F disk and everything. But now we came with LVM, which can do that, which can do the increase and decrease of a partition. So with the help of this approach, first creating a PV create. Next we'll be doing like a volume group create. Next we'll be finally creating LV, and of course increasing the LV size, decreasing the LV size. I mean, obviously. Now one last thing I want to show, as I mentioned right earlier, what if this VG is 0% free? Let's see that. Let's create one more LV, maybe LV create, sorry, LV create hyphen L 5.5 GB. I'll do it. Okay, 5.5 will be too much. 5 GB, because keep at least 500 MB free. It's a good practice. Of course, we don't need to keep it, but just for safe side keep it. 5 GB. Hyphen N LV3. The name is LV3. And which VG group? VG data. VG data. That's it. Created. Now VGS 548 MB free. Correct. Of course, now we have to mount it, format it, blah blah blah, all these things, which is fine. I mean, I don't want to do it again. You know it already. Or let's do it. That's completely fine. mkfs.ext4 file system. What is that? Slash dev slash vg data slash lv3. Oh, it's done. Format is done. Now you have to mount it, and you can use it. What's LVS? See, VGS now just 548 MB free. I want to increase it. How to increase? You cannot. How this in the first place? Imagine like how the space or how the size came to this VG with the PV only, right? From PV we have there are multiple volumes. This size came here as a together. So if you want to increase the VG data, it means you have to update the PVs. Obviously, you cannot extend the size of the XPDF1, XPDF2, those partitions, which is not possible. That's why what we do, we create one more partition number 3, XPDF3, add it to the PV, and then the partition will add it to the VG, which will size get increased, like that. So now we need to add one more partition, add it to the PV first. F disk, same command, sorry, sorry, slash dev slash xvdf n new partition, primary obviously, default 3, partition number 3, obviously that's fine. Now, what is the size? Just 1 GB free, if I remember correctly. Okay, plus 1 G, use it fully. See, now I want to change the type T 8E. I mean, obviously to LVM, I have to change it, right? Value out of range. Oh, wait, my bad. My so shit. No, no, no. I should have typed on 3 here, but I gave 2. Sorry, my bad. P. Let me just close it. Sorry, I did a mistake. My bad. Partition number I gave it wrong. Let's try again. First, let's say this 3 not K. Okay, XPDF only 2 are there. Let's create N to create, obviously primary partition number 3. First sector is default is fine. Second sector plus 1G. I mean, that's the last 1 GB size. Partition 3 is created. Next, what I have to do, I have to change the type of the partition. We call it hex code also. Type T. What is partition number 3? Hex code 8E. Last time I missed this. I gave 2 sometimes. I mean, which is my bad. See, if I give what happens 2 here, 2 already being used by LVM, which already has data, completely will be formatted if you do this. So always make sure, don't do it in a hurry, like that. Just make sure that you do it properly. Now it changed. W, save it. See, XPDF 3 1 GB came. Overall 10 GB, 8, 1 GB, 1 GB, 10 is finished. Okay, LB XPDF 2, XPDF 1, you're already using it. See the volume LB3. It's created on here. It's combined. If you see 2, it's showing in 2 places. It means maybe few space it's using from XPDF 1 and few thing XPDF 2, because it's combined because of VG. It's a one right over there. That's fine. Now just create a PV create from where the new is XPDF3 for new partition. Sorry, PVS. Okay, now see 1 GB is there. Now add it. We have to add it to VG. VG extend, obviously. VG data. This is the VG I want to extend. What is the new one? XPDF3. See, it extended successfully. VGS. See, now 1.5 GB is free. Earlier it was 500 MB, right? Now we added a new physical volume to this VG. Now 1.5 GB free. Now you can able to use it. You can able to create n number of partition LVMs out of this, whichever based on size, whatever you want. I mean, obviously. So we created a volume, created a physical. I mean PV. I added that PV to VG. That's why you gave the name. If you give, let's say, VG data 1 here, if that VG data 1 exists, it will add this volume to that VG. If not exist, it will throw error. So like this, you can able to increase it. There is no increase of physical volume PV, because these are just system partitions. These are just system partitions. Of course, we have done this now. It will show. See, these PVs part of this volume group, not just one volume group. In organizations, there will be multiple volume groups. So, for example, I'm just showing here one volume group, but there will be more. There will be more. Just the that's it. The names are different. That's it. Use whatever you want to use. LV create at the time you want to use VG data 2, you just mention it. That's it. That's all. That's all is required. So that's what about LVM. Most people use it. Sorry, most people use this one because of the advantage, as I told you. We can increase and decrease the data. Sorry, the size, not the data. That's the main reason. Increasing and decreasing, which is not possible by default in Linux machines. with this normal, FDisk and all. Got it? So that's about today's topic, LVM. Any doubts so far? Hmm? Anything? Of course, once you practice only you'll get doubts, because otherwise it will be just like this forever. So do we practice once, sorry, yeah, then you'll get doubts. Then you can ping me. Yeah, got it. So yeah. So but for now, anything you want to ask? Any doubts? Nothing. If nothing, yeah, I think we can close it. Uh, we'll meet tomorrow same time. All right. Till then, yeah. Bye. Keep practicing. Otherwise, is you won't remember it. If you don't practice, you don't, maybe by tomorrow it'll be gone. All of it. This is already present in the document which I shared in the Linux, kernel Linux. It's from Institute. I think it's clear. I mean, that is far more enough for a DevOps guy, with Linux. So you can yeah, take a look over there also once. All these present over there. Got it? Yeah. All right then. Yeah. See you tomorrow. Bye. Bye. All.